Hi everyone, my name is Quinn Graessle. I'm a master's student in CBE. Today I'm presenting about adjusting building performance standard targets for unit density in multifamily buildings. So I'm going to start by getting everyone on the same page about building performance standards, which you may or may not be familiar with, but they're essentially a policy that seeks to drive improvement in existing buildings in terms of energy and emissions. And so the way they do that is by setting targets, typically energy use intensity or EUI, or greenhouse gas emission intensity, and then they pair these targets for each building with deadlines. And if you meet the target by the deadline, you're in compliance. If not, you face a penalty, typically financial. And to illustrate how this fits in and its importance, on the left, a jurisdiction's typical building stock is going to have some small percentage of buildings under construction or renovation at any given time, and those are obviously covered by the energy code. But if you want to drive improvement in every other building, which is just sitting there, the vast majority of a building's existing building stock, that's where BPS comes in. And so these are catching on across the United States. This map illustrates jurisdictions that have either adopted BPS or have committed to the adoption, both at the state and local level. I also want to highlight that California has specifically committed to adopting BPS with State Bill 48. So by July 1st of this year, we're going to have energy and emissions targets, and that's in alignment with statewide energy goals. And so for this project, I wanted to contribute to this emerging policy landscape in a small way by trying to understand the impact that unit density has on EUI in multifamily buildings, specifically through a lens of trying to improve BPS policy equity. And so to illustrate unit density on the left, it's essentially the number of dwelling units in a multifamily building normalized by area. So a higher unit density building, shown on the bottom, is going to have more people per area than a lower unit density building. And so it might seem kind of intuitive that having more people, more plug loads, more kitchens in the same amount of area could result in a higher energy use per square foot, or EUI. But this is really an underexplored area and certainly not in the lens of application to policy. And so this research was inspired by two data sets that I had access to, one from the City of Berkeley that had both unit density and energy data, as well as a national data set. So this is the national data set, subsetted for California, and I've compared unit density on the x-axis in units per 1,000 square foot to site energy use intensity, or EUI, in kilobTUs per square foot per year on the y-axis. And so unit density typically ranges from around 0.5 up to 2.5. And we applied linear regression and saw a positive trend that, yes, as unit density increases, so does site EUI. And so this has an R-squared value of around 0.14, which is low, and it indicates that only around 14% of this variation in energy use is explained by unit density. But these results did have a high statistical significance indicated by the p-value, indicating that this trend is likely. It was also further corroborated by the local data set, which is shown here with the exact same axes. And you can see it's a very similar trend when you apply linear regression with a similar R-squared value, and statistical significance. And so this gave us confidence that this trend does exist. As unit density increases, so does energy use per square foot. And so to give you an idea of how this could be applied to policy, if the City of Berkeley were to adopt a BPS, it could look something like a flat target for all multifamily buildings. And so if they were to use their median EUI as a hypothetical performance target, it would be 28 kilobTUs per square foot. And so that's this red line. At the same time, this blue line could be taken as a density-adjusted median EUI for the City of Berkeley. And to show you how these two scenarios would impact one building, I've highlighted Hillegas Terrace, specifically because it's an above-average unit density building that's not meeting that red line target. So to put numbers to that, Hillegas Terrace is 36% above the median unit density in Berkeley, and they exceed that median performance target by 14%. Now, if you just take that blue line and make it a density-adjusted performance target, Hillegas Terrace falls 10% below it with just their benchmarking data. So that indicates that based on this regression analysis, Hillegas Terrace is a below-average energy user for their unit density. So this is a simple way that we could avoid punishing these denser buildings, which we know intuitively can be more sustainable. Fitting more people in less area is a good thing, and it's good for the environment, but it's not necessarily calculated in flat EUI. So that's my key takeaway, is that I feel unit density should be factored into BPS. I'm excited to continue exploring these results and ensuring that the models are robust and sharing those findings with both the City of Berkeley, as well as exploring the feasibility of adopting them in ASHRAE Standard 100, which is the Model Building Performance Standard. And as for my own next steps, I'm graduating this May and excited to join Taylor Engineers, an industry partner. So feel free to come talk to me about BPS today or anything else. Thank you.